Today, we're looking at some of the new advanced pump control features on the PD9000 multivariable controller. We have configured this device to control a pump down station with 3 pumps. These are controlled by a continuous level sensor, and 4 floats serve as backups. Discharge pressure and pump amps are brought in via 4 to 20 milliamp signals, and then other alarm parameters like pump temperature and leak seal integrity are monitored with digital inputs. The total run time for each pump is calculated by the device, and a maximum amount of time without any pumps running is configurable. The overall number of pump cycles is also counted, along with the number of cycles in the past hour. There is a function key hand-off auto, or HOA switch, for each pump, and many of the alarm set points can also be adjusted with a function key. Each screen has been configured to display a collection of values and is organized in an intuitive fashion. This is a specific configuration that is common in many applications, but many other variations of this configuration are possible too, so it is certainly still worth considering the PD9000 for any other pump control requirements with slightly different configurations. The first screen is an overview of the pump station. The level is shown in percentage, 0 to 100%, but could be scaled for any other engineering unit, including feet, inches, meters, gallons, liters, or pounds. There is a high-level alarm at 90%. Total discharge pressure is shown in PSI. Pumps 1 through 3 statuses are shown along with their total runtime, and then a low-level alarm at 10%. The bar graph is color-coded to match the corresponding value and has alarm set point indicators as well. In this instance, pump 1 and 2 are the lead pumps, and pump 3 is the lag pump. Pumps 1 and 2 will alternate with each other at the lead set point, and pump 3 will only turn on if the lag set point is reached. The lead set point is 60% and the lag set point is 70%. The lead pumps turn off at 20% and the lag pump turns off at 30%. Normal operation of this station will see the level rise up and pump 1 turn on when it hits that 60% set point after a slight delay. The status is updated on the screen and the runtime starts to accumulate. The pump will drain the liquid down to 20% when it will turn off after a slight delay. Delays can be configured for nearly any value, and a unique delay after power loss can also be configured. This will prevent all the pumps from being called to run at the same time when power returns. The next time the level reaches the same 60% set point, pump 2 will turn on after its configured delay. This is the alternation of the lead pumps at the lower 60% set point. Pump 2 drains down to the same 20% point and then turns off. Pumps 1 and 2 will continue to alternate with each other without pump 3 ever turning on. Only if the level rises above 60% and gets to 70% will pump 3 turn on. In this case, it happened to be pump 2 that was running, so pump 1 was skipped. If pump 1 was running at the time pump 3 was called, then pump 2 would have been skipped. Now, together, pump 2 and 3 will drain the liquid down, and pump 3 turn off at 30%, and pump 2 off at 20%. After their respective delays. That is the normal operation of the station. All of these set points are entirely configurable by the user to accommodate any application. If an abnormality occurs, an alarm will turn on. If the level falls below 10%, the low-level alarm will turn red and flash. The alert button also appears, which provides a list of which alarm occurred and an option to acknowledge. Now that acknowledge has been pressed, the alarm still shows until the condition has cleared. If the condition clears before the alarm acknowledge button is pressed, it still shows in the list to provide indication that the alarm occurred. A user can configure different alarms to require or not require a manual acknowledge, or configure some alarms to prohibit the pumps from running, as we'll see later. The next screen shows a detailed view of pump number 1. It shows pump number 1's status, including runtime and cycle count. It also shows the amperage of that pump and any head pressure it is creating. Finally, the function key HOA switch status is shown. The function key HOA switch positions are labeled above the corresponding button. If the hand button is pressed, the pump turns on and all of the other values on the screen are updated to reflect the status. The alert section turns yellow to indicate the status as well. If the pump is put in the off position, it will never turn on regardless of any other input or programming function. When placed in automatic mode, it will behave according to the device's configuration and the level in the sump. Pump 2 has its own detailed screen, and pump 3 does as well. The next screen shows the float and level sensor statuses, plus all of the pumps. If the continuous level sensor were ever to fail, the floats would still be able to operate the station. There is a low float, a lead float, a lag float, and a high float. The low float acts as a permissive to run the pumps. If it is not on, no pumps will run when in automatic mode. The lead float alternates between pump 1 and 2, and then the lag float controls pump 3. The high float acts as a high alarm. When the lead float closes, then the next pump in the cycle turns on. That pump on causes the lead float to open, and then that pump turns off when the low float opens. As the station fills again, the low float closes first, and then finally the lead float closes again. This time it is pump number 2 that turns on, continuing the alternation from pump number 1 the previous time. Pumps 1 and 2 will alternate continuously at that lead float point. If the level continues to rise and the lag float turns on, then we will see pump number 3 turn on. Finally, a high float on causes a high alarm. As the level falls, the floats begin to open until finally we get down to the low float, at which point we will see both pumps turn off after a staggered delay. This screen shows all of the alarms associated with pump 1. There are 2 categories of alarms, critical and non-critical. A critical alarm will prevent the pump from running, while a non-critical alarm will allow the pump to continue to run if called. A user can configure which, if any, alarms are critical and which, if any, alarms are non-critical. In this instance, high amps, high pressure, low pressure, and maximum starts per hour are non-critical, and over temperature and seal fail are critical. If pump 1 is running and a high amperage alarm occurs, pump 1 will still continue to run down to its reset point because high amperage is configured as a non-critical alarm. Even after the condition clears, there is still an alert to provide indication that the alarm did occur. If pump 1 is running and a critical alarm occurs, like over temperature, Pump 1 will turn off, and pump 2 will turn on in its place. Pump 2 will operate as normal and turn off at the same set point. Pump 1 will not turn on even if the level rises again to 60%. It will only ever be pump number 2 while pump number 1 is in critical condition. Normally they would be alternating between each other during these cycles, but because pump number 1 is in critical condition, it will not turn on. Only after the condition has cleared and the alert is acknowledged will pump 1 ever turn on. The number of pump starts per hour is useful information to know when optimizing a pump station. In this case, excessive starts by pump 3 could indicate an issue with either pump number 1 or pump number 2. This screen shows the number of starts during the current hour and the number of starts during the previous hour for each pump. A user can configure a set point to activate an alarm if too many starts occur in 1 hour on any given pump. This set point is easily adjustable by pressing a function key on the screen. Any other alarm set point is easily adjustable in a similar fashion. In some low flow stations, significant time can pass between pump cycles. This can mean that odorous liquid is present for an extended amount of time. For that reason, a user can configure an amount of time that will call the next pump to run. A pump will only run if the low float is closed and will run until the low float opens. When the pump turns off, the timer resets and the cycle starts again. Anytime a pump runs as part of normal operation, the timer stops. Once the pump stops, then the timer will reset and restart. This timer value is easily configured to any amount that may be desired by our user. As demonstrated, the PD9000 now has multiple advanced pump control capabilities that serve a variety of common and unconventional applications. It has the ability to control numerous pumps, receive analog and digital inputs, offer function key HOA switches, and track multiple pump parameters. All of the scales and set points are easily configured. We hope you consider the PD9000 for your next project.